calculate the sine and cosine of each of the following angles. Refer to the math notes box in this lesson. So it doesn't sound like they even need me to find the sine and cosine of the angles. It sounds like they just want me to say what the reference angle is. So a reference angle is an angle that's found in quadrant 1. So I'm going to draw each of these in whatever quadrant they're in. Like this one's in 330 degrees. So 330 degrees, you imagine that you're opening up from the positive x-axis, like you're opening up like the hands of a clock going counterclockwise. So that's 90 degrees. There's 180 degrees. There's 270 degrees. I'm almost there. I need 330 degrees. There's all the way around would be 360. So I'm gonna just back up by 30 degrees. So this 330 degree angle, it's almost 360 degrees. It's almost all the way around the circle. So what's the reference angle? The reference angle is the angle in, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. The angle that's just like this angle, but in quadrant 1, is the reference angle. So if you were to make this radius into a hypotenuse and draw a right triangle, this angle right here is 30, isn't it? Because it was 330 degrees, and that's almost all the way to 360, back up, that's 30. So the reference angle is going to be 30 degrees in quadrant 1. It's the angle, it's the triangle that's just like it. Or if you're talking about like the Screamer ride, it's the person who is the same height off the ground, the same angle of rotation. This is 30 degrees. Okay, 120 degrees. So I'm going to draw an angle. Oh, where is an eraser when I need one? Wait, oh. I'm going to draw a new angle. I'm going to draw an angle for 120 degrees. So 120 degrees would go open there. That's 90. That's 180. Oh, 180 is too far. It's somewhere in quadrant 2, because if I open up an angle to 90 degrees and just add a little bit more, 90, 100, 110, 120. So maybe it's about right here. That's about 120 degrees. It's 90 degrees plus, well, 30 more. So that leaves me 60 degrees right here, if that makes any sense. Or in other words, I could go 180 minus what equals 120, because we know halfway around the circle is 180 degrees. So the reference angle is going to be the triangle in quadrant 1 that has the same height and the same distance from, I don't know, the origin. Basically, it has the same cosine. This is cosine, and that's sine. So this triangle, which is identical to the other one, but it's in quadrant 1, is a 60-degree angle. So this one, we're going to say the reference angle is 60. Okay, now here's 113 degrees. So 113 degrees, we can do it. We're going to open up an angle. Let's use this little pen to open an angle. Okay, so 113 degrees. So there's 90 degrees. There's 180. Oh, that's too big. 180 is too big. So it's somewhere, it's 90 degrees plus a little bit more. So it's not as big as 120. So maybe it's just like, maybe it's right there. And we're going to call it 113 degrees. And then we're going to draw a right triangle. And then we know that there's another right triangle on this side. that is congruent to that right triangle. Okay, now I don't know what, I know this is 113 degrees. I don't know what that little angle measure is. So what I could do is I could maybe subtract from 180. I could go 180 minus 113, because if it's all the way down, it's 180. And if I back it up by this much, it'll be 113. So I can just, I think it's 67. So on this one, we backed up from 360 degrees. On these two, we backed up from 180 degrees. Or in other words, I subtracted from 180. So I'm just making it really clear how I'm getting these answers. You probably can't tell that that says 30 degrees. My pencil's dying. Okay, 203 degrees. Where would that be on my unit circle? Well, I guess we're going to have to find it. So if I opened it all the way up to here, that would be 90. And then that would be 180. And it's more than 180 because it's 203. If I went all the way to there, that would be 270. So that's too much. So it's somewhere closer probably to 180. So we're going to say that it's right here. And we're going to call that 203 degrees. Okay, I don't know this angle measure, but I want that. I want that, like if this is a right triangle, I want that little angle measure. So I think I can just go 203 minus 180, and that'll give me that little bit right there. So well, that little bit there is only 13 degrees. Okay, so that's my reference angle. I said it would be in quadrant 1. It's because there's 4 triangles that are like this. There's one here, there's one here. There's always 4. And if you remember our work that we did with the Screamer ride, this quadrant 1 triangle, this has 13 degrees right here.